All right, so let's work through some examples of how to compute partial derivatives. So let's start with x squared sine y, and we'll compute both partial derivatives of it. So when we do d dx, then in this case, we're thinking of this whole expression here as a constant because there's no x's in it, so it's independent of x. So this is the same thing as the derivative of x squared c, just usual derivative with respect to x. So that's going to be 2 times x times c, because you can pull a constant out of a derivative. And then I'll replace this c back with what it really is supposed to be. And if we look at the partial with respect to y of this same expression, now in this case we're looking d dy, and there's no y's in this expression, so I'm thinking of that one as a constant. And so this is going to be the partial with respect to y of c sine y, and then you know that you can just pull the constant out. So this is going to be c times the derivative of sine y with respect to y, which is going to be cosine y. And then I'll replace that c with what it's supposed to be, which was x squared. Okay, and so this technique of putting the c in and out again, I don't expect you to do that. You can do it in the beginning when you're getting used to things like that, but it's more of an illustrative technique than something that anybody actually does in practice when they're computing things. So let's look at another function of 2 variables. We'll take x over 1 plus y. Oh, sorry, I meant to take sine of this expression. And we'll compute its partial derivatives. So we've got df dx is, so let's see, so we're going to take, now we're going to need the chain rule, because this is sine of some function of x and y. So it's a composition of functions. So we'll differentiate the sine part, so that'll be cosine x over 1 plus y. And then we'll have to multiply by chain rule by d dx of the inside expression. And so again, I'm thinking of this as, actually, let me just rewrite it the way I'm thinking of it. Cosine x over 1 plus y times d dx x times some constant that goes by the name 1 plus y. Okay, and so this part here I can pull out of the derivative because it is constant with respect to x, and we're doing a d dx derivative. So we have cosine x over 1 plus x just coming along for the ride. And then we've got 1 over 1 plus y, and the derivative of x is just 1, so we're all done. If I do df dy of this same expression, then the first part is going to be the same, namely we just differentiate it, so it's going to be cosine of x over 1 plus y, now times d dy of x times 1 over 1 plus y. And so now I can pull out the x because it's a constant, and this other part here is a 1 plus y to the power minus 1, which is a nice way of thinking about it for how to differentiate it, right? So this is cosine x over 1 plus y times x, and then the derivative of that expression is going to be, let's see, so the minus 1 comes down, and then we've got 1 plus y times the derivative of 1 plus y, which is just 1. And this is now to the minus 2 power. So we're done there. Then, or I guess we could rewrite it a little bit if you care about making things pretty. How about minus x cosine x over 1 plus y times 1 over 1 plus y squared. There we go. Let's see, and I guess that's chain rule. I guess we didn't do product rule yet, so let's do one for that. Let's take our function to be y e to the xy. The exponential function, everybody's favorite function because it's the easiest function in the world to differentiate. All right, so if we do the partial with respect to x of this guy, so this is d dx of, and then I've got y, which is for our purposes right now a constant, times e to the xy. So the y comes out, pretending it's a constant, and then I have the derivative of the exponential function, which is just itself, and then by chain rule I have the derivative of the exponent xy, and the derivative of xy with respect to x is just y. So I get y squared e to the xy. And if we, now when we go to do it with respect to y, we have a product of things, both of which contain y, the variable that we're interested in. So now we have to use the product rule. So we're going to have d dy of y times e to the xy plus y times d dy of e to the xy. And so for the first one, the derivative of y, that's just 1, so we just get an e to the xy. And then for the second summand, we have y times, and then we differentiate that with respect to y, and we're going to get, so we get the e to the xy right back again, but then by chain rule we multiply by the derivative of the exponent, and d dy of xy is x, so we multiply by x. There we go.